And just, it is now being recorded, so you can watch this at a later date, or we can certainly get it to folks who were unable to make it today, and they can watch it at a later date as well. So, without further ado, he didn't come here to hear me talk. It's Francois' show, so I'm going to pass the floor over to Francois, who's going to give you all the nitty gritty on the Kinghome heat pumps. So, Francois, over to you.
Okay, yes, thank you, Chris. So good morning, everyone. Today we will talk about the Ultranixx. So this heat pump is for a very low ambient temperature. And after this one, we're gonna talk about the new A-coil model. So let's start right now talking about the Ultranixx. So this heat pump is up to 20 SEER. So it's a minus 30 degrees Celsius heat pump. You can use it in very cold climate. It's it gets a full performance down to minus 10 degrees Celsius. Very quiet operation though. So 56 decibel. And the most important thing, so you can match this unitary heat pump with any kind of air handler or furnaces. So you can match it with a A-coil or whatever coil using a thermal expansion valve. So this heat pump using a two-stage inverter compressor. So it's an inverter compressor, so you can vary, it can modulate its power. This heat pump is 24 volt compatible, already built in. So you don't have communication issue between the indoor unit and the outdoor unit because it will be simply like 24 volt connection. So from the thermostat to your furnaces to the outdoor unit. It's also has a small footprint. So compared to other type of unitary heat pump or the outdoor unit, well, this one has a smaller footprint, and so that's gives you great flexibility because it's compatible with any kind of indoor unit. So today we're gonna talk about preparation before your installation. We're gonna view also the indoor unit installation. So how the kind of, the air handler that we at Kinghome we have available to you. And also we're gonna see through the outdoor and unit installation, we're gonna talk about the piping, pressure, vacuum, really important. We're gonna go on with the electrical wiring and the test run, the startup, like all you need to know about adjusting the unit to a good, a proper installation for your customer. So let's start with before you get that installation process on. So thing is, it's really important to have a good equipment sizing and duct sizing, duct design. So the load calculation is the thing. You need to know exactly what the house needs. So to just being sure you're not oversized or undersized. There's a lot of parameter that you can fine tune with the unit, but at least at the beginning, it's really important to know exactly what is your load calculation for that house. So you will need also just to be equipped properly. So the materials and all your tools must be compatible with, for now, it will be R410A, but this year, so through year, in the summer or lately in fall, we will have the new refrigerants coming. So it will be for most of those type of unit, we will switch to R454B, and then for all the dockless type of unit, it will be R32. But if we going forward with this R454B, you will have to have the proper tools required for this new refrigerant also. So be sure you have all your tools according to the equipment, and make sure you have all the bottle serial numbers, all the stuff that is required to get the proper warranty about on the unit at the end of your installation. So when you're on site, really important, make sure your installation site will be where you will install the unit. You will have the proper ventilation around the unit. We will talk about all the requirements around the unit. So make sure you are not too close to the neighbor, away from plants and animal or whatever that can block the outside coil. Stay away also from strong winds. Most of the time, strong winds may generate some issue with any kind of heat pump. So just be aware that if the unit always have strong winds going through the condenser coil, that may cause some problems to the unit. So all easy drainage, the condensate drainage, so the heat pump will do some defrost. So make sure it's high enough from the ground to get a proper drainage of that defrost mode. About the electrical safety, well, you must be conformed to the nameplate. You must have a power, a stable power. So somewhere between 187 to 253 volts. Nothing less than that, nothing more than that. So you have also you need also a proper grounding. So this is really important because you have all those electrical board inside of it. There is no communication between the indoor and the outdoor unit, but there is some sort of communication inside the unit. So the ground is really important at this point. So a proper grounding for the unit, it's a good thing to focus on. And also the use of a surge protector is optional, but it's highly recommended. So to prevent from lightning strikes, or if the power in that home is fluctuating a lot, well, this little device here can for sure save all the electrical component inside that unit. So this little guy here can take the hit one time. So just make sure that if it's when you will do some servicing, some stuff, make sure that you will you will have to make a little service about there's a little LED here. So if it's off, well, you need to replace this little device because it's like taking power. So let's move on to the indoor installation. So at Kinghome, we have this model here of air handler. So this air handler comes with 4 tonnage. So we have a 2-ton, 3-ton, 4-ton, and 5-ton. You can fit any kind of electric heater, even if it's a 2-ton unit, you can go as high as a 10 kilowatt. But when you are on a 4-ton unit, you can go at a 20 kilowatts. In your region, I know it's not really a thing here, but it's going forward with the changing of gas to electric and all the stuff. So just be aware that we have this type of unit available. If you need some we will go through this kind of unit about the installation and all the stuff. So we have here all the size of the units, and what it's really important to know about these kind of unit is you have some service valve. You have service valve here on the indoor unit as well. So that's a good add to this kind of installation, because you will, on the piping side, you will flare inside and you will flare outside, so no welding. And also you will have to make your pressure test and vacuum only in the piping, not even in the coil. So that's a good, that's really awesome with those kind of unit, because you will save so much time installing those units. And the thing is about these kind of air handler is you will have to remove the front panel to gain access inside of it, but also you can remove the top panel here. So to have a proper access or easier access to install the electric heater, you can remove this top panel right here. So I just recommend you to, when you will do the ductwork, just be sure that you will fit only on the A and B section right here. So your first duct must be like 12 by 20-ish, like around those, this little gap right here. So just to make sure you will gain the access here on the top panel, you can remove it if you need to access for servicing and like to have a better access. So what's inside this air handler? Well, you will have your electrical box assembly, you will have your blower motor, and inside of it you have the A-coil with 2 drain pan. So the primary drain pan here and a secondary drain pan if you do change the orientation of this air handler. So around the unit, you can have as low as 1 inch all around the unit, but in front of the unit, we suggest to have a minimum of 24 inches clearance, like for the service and all the connecting from the piping and the power and all the stuff. So 2 feet away from the front door of this air handler, it's a good thing to have. This unit can be installed horizontally, so it can be left side or right side configuration. The thing is, when you flip it on the left side, the secondary pan is already on the good spot, so you don't have to make any modification inside of the unit. But when you flip it on the right side, you will have to just move the secondary pan to the other side. So you will have to remove the coil right here and change the orientation of the secondary pan, and then you will have your right configuration. Moving to the A-coil. So we have also, talking about the indoor unit, the A-coil. So this is a Kinghome A-coil. Also, you have the same kind of service valve. So you can have access here to your pressure. You can front seat it, back seat it. And also it's flare 3/8, 3/4 on the suction pipe. So really easy to manage and to install. Also available in 4 kind of sizing. So 2 ton, 3 ton, 4 ton, and 5 ton. and I have here all the dimension of this A-coil. So you'll see for a 2 and 3 ton, we are using the same casing. Okay, and for the 4 and 5 ton, it's a little bit wider, but it's also the same casing for the 3 ton and the 5 ton. So if we match those A-coil with the outdoor unit, the Ultranixx outdoor unit, well, we will see a little bit further, but the outdoor heat pump has 2 different casings. So you can have a 3-ton unit in a 5-ton unit casing, but it can be changed. You can change the capacity of a 3-ton unit to configure it as a 2-ton unit. So you can fit a 2-ton installation process with the 2-ton A-coil right here, or you can stay at the 3-ton and you will use the same heat pump, the same outdoor unit. Same thing happened with the 5-ton. You can configure it as a 4-ton, so you can use the 4-ton A-coil right here, and you can just have the same kind of outdoor unit, but it will be configurable as a 4-ton unit. So what's inside that A-coil? So we're using thermal expansion valve. So there's no power needs to be had to this kind of A-coil. It's only a thermostatic expansion valve. You will find some strainer at the inlet and the outlet of that valve. Also, you have a cutoff valve, so a service valve, a 3/8 service valve on the liquid line, and on the suction line you will have a 3/4. So every size, any size of units, so from 2-ton to 5-ton, you will use 3/8 on the liquid and you will use a 3/4 on the suction line. Also, you have a primary pan, drain pan right here, and you have built in a secondary drain pan. So for the A-coil, you have multiple position you can do. So if it's a vertical up kind of installation, well, you can fit the A-coil directly on the furnace, or you can do a downflow application. So with the A-coil as well. You can add a field installed transition between the A-coil and the furnace. Even it's a downflow or upflow installation, I recommend you to always install a small piece of ductwork between the A-coil and the furnaces, because that will help you to reduce the static pressure, the differential here in your ventilation. So by adding a small transition piece of ductwork right here, that will help the airflow to go through the A-coil and reduce the static pressure out of the system right here. So maybe sometimes when you have some airflow issue, when adding a small part of ductwork here, that can reduce the pressure in the ductwork. With the A-coil also, you can do your horizontal left or right orientation. So again, if it's a horizontal right operation, you will have to relocate the drain pan. So by default, it's always fit on the left side. So you will need to just remove the coil and flip the pan, and you are all set for your horizontal right installation. Talking about the drain, so you have a 3/4 outlet drain that is by default. So the P-trap here on the drawing is optional. I know when the A-coil is in the supply here, so you have positive pressure right here. So you don't need to install this kind of traps. But if you go straight, the thing is, you must make sure you have a small part, like you will reduce the pressure right here. So by the flow, so the water will drain right here in the floor drain right here. But the thing is, you will push some positive air pressure into the drain line as well. So when it's separate from the furnace drain, it's good. But in the case that it's joined together right here, make sure to have a vent or something that reduce the pressure, the air pressure here in the drain line, because otherwise it will create a problem with the flow switch or whatever in the furnace. So just make sure you have a small vent right here, and when the blower will be on, you will not push excessive air pressure back to the furnace drain. Also, what is really important when you will do your startup, or when everything is installed properly, you must take the static pressure measurement. So you will need your digital manometer, and these kind of static pressure tool to measure properly the static pressure between the return duct and the supply duct. So the purpose of measuring the static pressure is to measure and make sure you have the right amount of CFM going through the coil and the furnace. So either way, it's an air handler or it's a furnace. So only the coil will be in the supply, versus now it's on this picture is in the return here. But you will have the same kind of measurement to take. So in that example, it's an air handler. You will just make a little hole in the return side of the duct after the filter, and in the supply duct right here. And you can take the differential between those two. That will give you a number in inch of water column. So you can refer to the chart of CFM. For example, this is a 3-ton unit, and on the Kinghome air handler, and by default, we know that we are always at speed 4. So regarding the static pressure I have right here, so I can refer to my static pressure, my measurement right here, and I can already know what's the amount of CFM is going in my supply duct. So by doing this at the first startup of the unit, this is really helpful to for you guys to manage if you have some airflow issue right at the beginning. So you can refer to your furnace installation booklet, and you will always find this kind of chart in every kind of furnace or air handler. It doesn't matter, but the way to measure the static pressure in your ductwork still the same, even if it's a air handler or a furnace. Do you have any questions about that? No, everything is good? Perfect. So don't be shy if you want to interrupt me during the presentation and ask questions. You can go ahead. So just unmute yourself. Yep.
Hi, sorry to interrupt you there. We do have a question in regards to the airflow.
Okay, so how much airflow per ton we are using these GREE heat pumps?
Well, the airflow is about the indoor unit. So
what we are recommending per ton from the for GREE heat pumps?
Well, everything around 325 to 400 CFM per ton.
No, normally in air conditioning, we are using 400 CFM per ton. This is thumb rule. And for heat pumps, we are using a little bit more airflow rather than the conventional air conditioning. So if we are going to use from 325 to 400, will they work nicely or?
Yes. Yeah. Well, 400 CFM per ton is, well, for me, it's the maximum you can use, because you want to make sure that the air makes enough contact with the fin of the coil to take all those temperature differential in the coil. So by reducing your airflow just a little bit, somewhere between 350 to 400, so the system will work perfectly at that point. If you have more than 400 CFM, the thing is you can you may have water, so the condensate water can be blown out of the coil, so you can have some leak, some water leak if you are over than 400 CFM. And also the performance will be reduced. Like you will not have the proper temperature differential because you have too much air. And at a certain point, regarding how you did your ductwork, if you have more than 400 CFM, it will be very noisy. So in the house, your static pressure will be very high and it will be very noisy. So make sure you will fit around 400, maybe a little bit less. So for example, here we have a 3-ton unit, and if I go with a 400 CFM, my maximum CFM will be 1200. So this is for air handler, but you can do it as well for a furnace. You can change the CFM on your, or you can change the speed of the blower on your furnace. So the thing is, we need to be somewhere between like 1050 to 1200. So by having 0.3 right here, that's my maximum CFM I can have with a 3-ton unit. If I do my measurement and I have more than that, so my speed is at 4 and my static pressure is 0.2, I know I'm a little bit higher than it's recommended. So what I will do, I will change my speed to speed 3 and measure again and make sure if I get the same static pressure, I will reduce my CFM. And also I will be sure of what am I doing. It's not just a try and guess. So you will be able to measure it and make sure you have the right amount of CFM passing through that coil. So all those measurement is, well, the first thing first, reduce the pressure in the ductwork, so reduce the noise, but also have the right amount of air going through that A-coil and provide the right rising of temperature in the ductwork by using the heat pump.
Okay, and another thing, that what is our ideal static pressure we recommended for our units?
Well, there is no idle static pressure. It's all regarding how the ductwork is built.
Okay.
So I know multiple ductwork installer or whatever. When you will design your ductwork, they will design it maybe as a 0.5 or 0.4 static pressure by default.
Yes.
So regarding that, if you know exactly what is your design, so if the ductwork is designed already for 0.5,
Yes.
well, you will manage your fan
Yes.
speed regarding at 0.5. But
Yes.
by taking the measurement, that will assure you that you don't have, for example, a filter that is clogged, or some ductwork that is blocked in any way. So you will make sure your system is at 0.5 or 0.4,
Okay,
whatever.
so whatever your chart is, this is showing for 3 ton on speed 4, and if your duct is designed for 0.5 inch of water column, so that airflow gonna come down to 830. That will be enough.
No, you will have to change it.
Okay,
You will
so
have to change it to speed 5, in that example.
okay, so for this you are talking about your own air handlers, Gree?
Yes.
Okay, so this air handler has
Kinghome.
another option for speed 5 and speed 6.
Yes, you on this Kinghome air handler, you have 8 speed you can select.
Oh, okay.
But even, well, this is with our brand of units, but with a gas furnace, you will have also a different speed level that you can select from your blower.
Yeah, yes.
Can be low, medium, high speed.
Yes.
So I know by default, using air conditioner, we always recommend to use high speed. But regarding that, if you take the measurement and make sure you have the right amount of CFM, well, maybe medium speed can be the perfect fit for that home. So this is why you need to take those measurements to just make sure, to assure you have the right amount of CFM. So you need to pull out the manual of your furnace or your air handler, and then
Okay.
take this this chart right here, and just by taking your measurement, make sure you have the right amount of CFM.
And on this air handler, to change the blower speed, is it dip switches or just changing around wires off the board?
It's dip switches.
Perfect.
Yeah. So you just put the power off, change your dip switch,
Yep.
bring the power on, and retake the measurement again.
Yep. Thank you very much.
No problem, sir. We're just moving forward with the outdoor installation. So I already talked about, there's 2 kind of outdoor unit, but the 3-ton unit can be configurable as a 2-ton, and the 5-ton can be configurable as a 4-ton. So the pipe size for any kind of unit will be 3/8 and 3/4. You can have a maximal length pipe of 98 feet, and the drop between those 2 units can be 49 feet. So again, make sure you have, when you will install this outdoor unit, make sure you will have a proper ventilation around the unit, and you don't have, you will not have an inlet or outlet obstruction. So in front or behind the unit or whatever, you will be away from strong wind, and you don't have the gutter, the water falling on the unit directly, and all this kind of basic stuff around how to install an outdoor unit. So regarding that, I've put out the chart here. So just make sure, for example, little B right here. So behind the unit, so the condenser coil is right in that section right here. So to have a proper airflow entering the unit, make sure you have at least 4 inches. So on the wall behind the unit, so 4 inches is the minimum distance required between the unit and the wall behind it. So on the left side of the unit as well, 4 inches is recommended. So you can install this unit in a corner, but 4 inches from the back and 4 inches from the left. The little A right here, so you will need this to have access to the electrical stuff and the piping stuff. So it's recommended to have a minimum of 12 inches. Well, as a technician, I hardly suggest to have more than that because you will have to fit your body just right here to check all the electrical stuff and the piping. The front panel here can be removed, so you can have also access here to the installation and servicing parts. But in front the unit right here, to have a proper ventilation around the unit, so little d, it will be at least 40 inches. So why is that it's long as that? Is because we don't want the unit to push the air out of the condensing unit and get them back, so the unit will recycle the same air always. So by having 40 inches in front of the unit, so that's making sure the air that's passing through the outdoor unit will be pushed away, so it will not recycle the same air in the space, because that will cause you at least by time some problems if the unit recycle the same air again and again and again. Same kind of requirement if you have multiple unit installed. So 4 inches in the back, 4 inches. Well, if you have multiple here, we recommend 16 inches, but same 40 inches in front of the unit. And so you can have multiple units side by side like this. If it's installed in a row, well, at this point, by if units is facing back to back, right, like this, 8 inches is recommended. And if they are facing front and front like this, 160 inches is recommended. So we don't want this unit pushing the air through the other one here. So by having 160 inches between those two, they will not push the air into the other coil. So if you have a multiple row like this, you will use the same kind of installation. It's a little bit more if you have multiple here, so 24 inches, and maybe you can go as far as 180 between those kind of unit.
We wouldn't get it back to like 2. I'm like, no, waiting till then.
if the unit is installed one above the other, well, at least you will have to put a clearance of 20 inches between those units, and just make sure you will have enough space to remove the water from the defrost cycle. So make sure the water will not drip on the unit just below, because that can cause some icing problem on this one. So make sure you will have a proper rack or a proper level to the outdoor unit. So regarding the average of snowfall in your region, I know for me, I'm in Quebec, so it's out at least 20 inches. I need to put this unit high enough. But in your region, if it's a little bit less than that, well, make sure you have the proper rack to like not have an accumulation of snow building in front or behind the unit. So what's inside this unit? We will start here the process. So with that chart here, we are in cooling mode. So the heat pump can do cooling and heating as well. So we will start with the cooling mode, and I will just explain to you what's going on with this unit. So at first, we are here at the compressor. So through the compression, the low refrigerant pressure is compressed, and it will be changed as in high pressure vapor type refrigerant. So the high pressure will go through directly the reversing valve. And in cooling mode, the reversing valve is not energized. So by default here, there's no voltage on the reversing valve. So the high pressure will flow through that valve and will go into the outdoor coil. So passing through that outdoor coil, you will have some flash gas, some liquid, and vapor at the other end. And so we will hit a first EEV, so electronic expansion valve. This valve will just assure that the refrigerant on the other side is 100% liquid. So by removing the BDU out of the refrigerant, the vapor state will change to a liquid state. So this valve will just assure that the system is 100% liquid at this point. So going out here, it will drop into a gas liquid separator. So this cylinder here will be full of liquid refrigerant. On the other side, the system will pump out 100% liquid refrigerant, and we will hit a bypass right here. So we have a secondary EEV, but in cooling mode, this one is not in use. So the refrigerant will flow by the easiest way, and it will hit this flow switch, well, this one-way valve, and it will go out to the indoor unit. So at this point, it can be your air handler, or it can be the A-coil. So on the A-coil, we will have a thermal expansion valve. So at this point, this metering device will reduce the pressure. So we will go from high pressure liquid refrigerant here, and we will have low pressure refrigerant on the other side of that valve. So we will hit the indoor coil, and we will gain BDU inside of it. So on the other side, you will have your flash gas. So a mix of liquid and gas refrigerant at low pressure. And we will go back to the outdoor unit. We will pass through that four-way valve again, and we will hit the accumulator right here. So this is another tank, like we can call it like this, to protect the compressor from pumping liquid. So in that point, if you have some kind of, well, a small amount of liquid, the accumulator right here will stock this liquid refrigerant. So this other pipe here will just take 100% vapor refrigerant at low pressure, and the process will start again. So this is how this Ultranixx heat pump is working in cooling mode. If we go in heating mode, well, the process will be changed just a little bit. Compressor will do his work as normal, and we will, on this reversing valve, now in heating mode, this reversing valve is active. So you will have high power, so 240 volt on the reversing valve coil. So inside of it, the small device, well, the electronic valve, magnetic valve, will change its way, and then your high pressure will change direction, and it will be sent directly to the indoor coil. So the same process will, well, inside of it now it's hot refrigerant. So inside your house, you will have warm temperature going out. And then the thermal expansion valve is equipped with an internal bypass. So this is not acting like a metering device in that case. So that thermal expansion valve is not in use in heating mode. The refrigerant will flow through and without restriction. It will go back to the outdoor unit, and then because here the valve is blocked in that direction, we will hit the first, well, it's called the EEV number 2, but we will hit that EEV, and this EEV will act just to make sure you have 100% liquid refrigerant after that EEV. So we will have at this point 100% liquid refrigerant that's going into that gas liquid separator. This cylinder is equipped with a third pipe. So there's a third pipe right here, okay, equipped with an electromagnetic valve. So in very cold weather, when the compressor has difficulty to pump the refrigerant and it's so cold outside, so the refrigerant pressure is dropping dramatically, well, this unit is equipped with a vapor injection. It's called like that. So we will take a small amount of hot vapor refrigerant right here. We will open this electromagnetic valve for a second, something like ish, okay, a small amount of time, and we will inject hot vapor refrigerant mixing with the low vapor refrigerant right here. So the compressor will gain some high compression. So in that point, the pressure at the outlet of the compressor will increase. So that will increase the performance of the entire system. So we are here in that tank. So we will pump 100% liquid refrigerant out of it, and we will hit the first EEV right here, and this one will act as your metering device at that point. So your high pressure right here is going to be low pressure on the other side. And then you will hit the outdoor coil and going back through the reversing valve and then go back to the accumulator and on the compressor again. So this is how it's worked in heating. So the little difference between those two cycles is the reversing valve in heating is active, so the refrigerant will flow in a different direction. And also in very cold temperature, we will have this vapor injection process active when it's very cold outside.
Go ahead.
Whenever we are using this heating mode, and how the unit will determine that outside temperature is too low and it has to be inject some vapors from that accumulator to the compressor.
Well, it's all regarding, well, the algorithm of the system is built on the you have a sensor that senses the outdoor temperature, and also you will have a pressure transducer right here that will give to the system some information about the pressure. So it's an algorithm already built in the board of that unit, and when you will hit this kind of parameter, because the pressure is too low and the outdoor temperature is too cold, this electromagnetic valve will open for a couple of seconds and it will inject hot gas in the compressor.
So that means this electromagnetic valve has a wire coming from the control board, yes?
Yes.
And same thing with those electronic expansion valves, they have some control from the board?
Yes.
Or they're independent?
No, it's all control from the main board.
This electronic expansion valve number 1 and 2 and electromagnetic valve, the 3 are controlled through the board.
Yes, exactly.
Hey, Francois, we have a question in the chat box here. What are the typical pressures with the new refrigerant?
Well, I didn't have test the new refrigerant now. I will this summer, but R32 or R454B will be the same amount of pressure. Well, it will be slightly under the pressure we are seeing right now with R410A. So for the same amount of temperature, the pressure will be reduced just a little bit. So there's no big change in what we see now with the R410A between what we will see with the R454B. It will be the same amount of pressure.
Hey, one other question, Francois, that comes up a lot is with the Ultranixx, is a filter dryer required or not?
No, it's not. It's not required. It's not recommended to install it. The system has already some kind of filter inside of it, and well, we will talk a little bit later on with the piping stuff. So I will came back with this kind of information, but yeah, we will talk about that later.
Perfect.
I have a question as well, if you don't mind.
Yes, go ahead.
You were mentioning that you have 2 outdoor condensers, a 3-ton and a 5.
Yep.
I was just wondering, when you said the 5 goes down to a 4-ton,
yep,
what are you doing for the 3.5-ton unit, or the same thing on the 1.5?
There is no half-ton with this kind of unit, but through the fine-tuning at the end of the presentation, I will explain to you how to do it.
Okay, thanks.
No problem. So on this diagram right here is just to let you see how the vapor injection occur mixing with the suction pressure right here. So this is a two-stage rotary compressor, and by mixing that pressure together, that will increase our discharge pressure going out from the compressor. So this is why at -30 we still have a high heat operation with those kind of units. The heat pump is equipped with a base pan heater. So this heater in the base pan, well, is active at 1 degree Celsius, and it will be disabled at 3 degrees Celsius. So what it's meant is to just avoid to have ice building up in the pan right here. So you will have some hole in the pan to evacuate all the water from the defrost cycle. And so the heater here is just to prevent to have a ice buildup that can block the condenser fan. Also, the system is equipped with a low pressure switch and a high pressure switch. So those switches are for protection only. So if you have issue with the system and you hit 667 psi because something's blocked in case, well, the high pressure switch will open, it will shut off the system. You will have an error code related to that. Same thing as well for the low pressure switch. If you have a leak and you have less than 7 psi inside the unit, well, the low pressure switch will open and you will have an error code related to this error.
Hey, Francois, I've got a question here from John. He's asking, are the case coils the same as the coils in the air handlers, as in, do they have valves on them with flares? If so, are the coils in a vacuum or full of refrigerant?
Okay, even if it's an air handler or the A-coil, they are both using the service valve out of it, and they are already filled with R410A. So around like 8 ounces of refrigerant is already filled in. So when you will install those units, the service valve are front seat. So you don't have to touch in any way the service valve before you do your pressure test and your vacuum and all your stuff. So you will do vacuum only in the piping. So you will test by adding your nitrogen and make sure your flare connection is good. But and then when you will do the vacuum, it's only in the piping. So there's already an amount of refrigerant inside the A-coil and the air handler as well. So on this picture right here is just to show you, we saw on the diagram you have EEV1 and EEV2. So this is what it's looked like. So inside of the body right here, you have a screw, okay, and you have a magnet around it, and it's linked with some kind of gear. So when you apply power to that ring right here, you will you will rotate the screw, so you can screw it or unscrew this little pin inside of it. So this is, you have a small hole right here in the inlet of the valve, and then you can block that hole a little bit or open it a little more to have more refrigerant passing through that valve. So this kind of EEV have 500 step. They call it step. So it's the way you can open it. So by 0, it's fully closed, and if you have 500, well, it will be fully open. So the system will manage the opening of that valve regarding all the algorithm, the temperature of the outdoor air, the temperature of the coil, and also the pressure sensor will be involved in those. The pressure transducer, sorry, will be involved in this kind of algorithm to let the systems know how far it needs to open the valve or to close it.
Hey, Francois, just hey, can I just interrupt for a sec? There's a question, maybe a follow-up to the last question. Just asking, so no refrigerant in the condenser, only in the coils, or both?
No, both.
Perfect.
Both. So the condenser as well, the servo valve will be front seated. So you have all the refrigerant in the condenser coil, but in the indoor unit, the A-coil, for example, they had already 8 ounces of refrigerant. So on this diagram is just to show you the small reminder about those 2 expansion valve they are using in the outdoor unit, and the thermal expansion valve used in the A-coil or the air handler. So again, we have this kind of pressure transducer equipped on the system. So if I go back right here and the pressure transducer right here in cooling mode will sense the low pressure refrigerant. So in cooling mode, the algorithm will manage your superheat, in that, if we can call it like this. So the amount of pressure going back to the systems right here will be managed by the pressure transducer, and by having this information right in the main board, well, the compressor can increase its frequency or decrease it depending of what's the demand, the capacity demand for the unit right now. So just remember that this compressor is an inverter compressor. It can fluctuate its frequency or its RPM. So you can, by the capacity demand of the indoor unit, it will be translated here by the pressure transducer, and the compressor can go with a higher compression, or it can decrease its compression. So it's all managed by the pressure transducer right here. And in heating mode, well, the same pipe will be used for the discharge pressure. So the pressure transducer in heating mode can manage what is the amount of pressure going out from the compressor. So by using its algorithm, it can manage what is the capacity demand for the compressor, and moving forward, it can increase or decrease the compressor frequency by knowing this information. So it's not a on-off compressor. It will vary its capacity demand. So make sure when you will do some test and service to just not focus on the pressure, because sometimes they can vary a little bit. So you will need a full picture of the systems when you will do some servicing on those kind of units. So by knowing your outdoor temperature, your coil temperature. There's a lot of information you need to take out from that unit before doing some service call on it. So we will move forward with the piping, the pressure, and the vacuum. So as I said at the beginning, the length is the maximum piping you can have between the indoor and the outdoor unit is 98 feet. And also the for in that example, if the condenser unit is installed on a roof, and then you have your indoor unit or your case coil right here, the heights will be 49 feet. So, and it can be reversed. So it can be the compressor on the ground and the indoor unit like 4 floor away, but 49 feet, the heights difference is the maximum. So always use a nice and clean
sorry
copper.
to interrupt there.
Yep.
So 49 feet max height. If we're within max line set length, can we just install oil return trap there, or no? 49 feet is maximum. Like proper refrigerant piping practices dictate we can put in oil return trap there, but because it's a heat pump, does that it has its own oil return mode, or
Yes, it's its own return oil mode, oil return mode, and then you don't have to add traps because the pressure is high enough to bring back the oil inside the compressor.
So 49 feet is maximum, regardless of our refrigerant piping practices. That is, it is what it is, no matter what.
Yes.
Got you. Thank you.
No problem. So make sure you have always proper L-type copper lines, and also it will be nice and clean. So if you do some pre-installation, make sure it's capped properly in any way to avoid to have debris or whatever in the piping before you do your installation. If you have to use the brazing torch or whatever, you will have to braze with nitrogen. So this is mandatory. Okay, so you need to apply nitrogen while you're brazing to prevent to have oxide inside the cup. Okay, so when you don't use the nitrogen, well, oxide will be created inside of the cup, and we have inside the system, so the indoor and the outdoor unit, some strainer to protect the EEV or the TXV, and this scale right here will be with the mix of the refrigerant that will the refrigerant will act as a solvent, and it will dissolve this kind of scale right here in this small powder. Okay, and that will block some small orifice, so as your TXV and EEV, and that can be also be lodged in the base of the compressor, so that will create some issue with the systems in any point of his life with scale moving inside the piping. So to avoid that, you just have to weld with nitrogen. So that will just stop the oxide process inside of the pipe right here. So you will have nice and clean welding, and then no scale inside of it. So you can use when you will have those units, you will have some kind of a fitting already flare. So this fitting came with the unit, okay? So with the outdoor unit and the indoor unit, but it's not mandatory to use it. So if you can just put your piping and do your flare directly to the valve without using those extension that's provided with the unit, well, that's great. Okay, if you avoid to braze, that's awesome. But this unit will came with this kind of connection. So if you struggle to install to make the bend correctly with the piping, you can use those kind of extension already flare and you can braze it. But just remind that if you need to braze, always use your nitrogen to make sure you will not create oxide inside of the pipe here, and at certain point that will block the TXV inside of it. So at the outdoor unit, the 3-ton unit, the connection, the valve are inside the cabinet. So it's the only unit that have this kind of this type of connection, but you will have to bend your piping in any way inside of the cabinet, and so the connection will be inside the panel right here. So you will have your service valve, your liquid service valve and suction service valve, and you will have to flare your 3/8 and 3/4 pipe directly inside the unit. So saying that, you can use this kind of connection just to make sure you have a good 90 degrees bend right here, or if you can make it by yourself with the piping already up to the unit, well, that's better because you will avoid to use brazing in the piping. So when it's time to make your pipe connection, make sure you will use a torque wrench. So at the beginning, when I said you have to use the proper tool, the torque wrench is a thing that everyone must have. It's the only way you can measure how strong the pressure you apply on your flare connection. Also, you can use oil to reduce the friction when you will apply the pressure to make your flare connection tight enough. Most of the time, we apply too much pressure on a flare, okay? And that can create, in a certain way, the flare to crack, okay? Because it's too tight. It's too, the torque is too high on the flare. So by using the torque wrench, you will avoid that, and you will make sure that you apply the right amount of pressure for a 3/8 flare instead of a so the same thing for the 3/4 flare. So you can make your torque wrench in the Newton, and you can measure the torque for your 3/8 like somewhere between 35 to 40 Newton, or for a 3/4 somewhere between 70 to 75 Newton. So always use a second wrench or a spanner or whatever to hold the pipe correctly, to hold the valve, and then with the torque wrench, you apply the right amount of pressure. And by doing this, also by adding some oil, you will reduce the friction. So you will help the flare to move around the threads and not to grip the copper and make it twist at the same time. So by just moving the flare nut on the threads, that will make sure you have enough pressure and maintain that good connection over the year. Also, another tips that I can gives you this morning is when you will do your piping work around the unit or whatever, make sure you have some sort of like I don't want to say a P-trap, but some sort of S or something like around the unit. It's not going directly inside the house. Okay, so you will have your connection, and if you going directly through the wall at this point, the thing that can happen is the vibration and all the change of temperature between hot and cold. Because it's a heat pump, it will be very cold outside, very hot temperature. So the copper will try to expand and retract, and expand and retract. And the weakest point on the connection is your flare. So at anyways, if your piping is too tight attached on the wall or through well inside the house, and there's no place for the piping to move properly to take that expansion, well, your flare connection will take it, and maybe in a year or two that will create a leak. Even if the torque is good and the flare is perfect, it can create a leak because of the expansion and the contraction of the copper. That's a natural thing. It will happen, but if you can just on your piping work make some bends and turns and whatever, that will reduce the pressure on the flare connection. So make sure you just not throw in the piping in like straight ahead and add in some clips and some it's too tight attached to the wall or in the ceiling or whatever. Make sure the piping can move freely to take that expansion. So on this 3-ton unit, you will have also the knockoff hole. So make sure at the end of the installation, when you will put your Almaflex and all the stuff, the knockoff hole will be properly sealed. And also for your connection cable, so the high power and the low power cable, make sure every hole is properly sealed to avoid to have a small animal entering the systems and biting all the wiring and all the stuff. So make sure it's sealed properly. And also we talked about, we had a question about the filter dryer. So with that kind of unit, it's not recommended to use a filter dryer because we already use some kind of filter just to prevent to clean the system if anything happened with it. But also the filter dryer will gives you some sort of restriction into the system. So we don't need it. We don't have to use it. Well, if it's a retrofit and you feel comfortable to use one because you don't know what's going on in that pipe, or you're not able to make the vacuum good enough, well, you can maybe install in one on the liquid line for a certain amount of time, but in a way you will have to remove it because we don't need this kind of restriction in the piping. So the
Hey,
pipe
Francois, can
Yeah.
I just interrupt for a second? Silas has a question about the knockout hole. Will this be included in the units at some point?
how to block it.
Yeah. Hey, Syke, maybe you can expand
No.
on that.
No, there's no foam already sent with the unit, so you will have to block it by on the field, directly on the field.
That side, did that answer your question?
Sorry, Francois. Yes. So what do you recommend we fill the hole with? 'Cause it's a fairly large hole.
Yeah, I know. I'm using Armaflex, Armaflex pad
Yeah.
directly. You can add
Okay.
some little bit of glue or whatever, and with
Yeah.
Armaflex pad, that's making a great job.
Yeah. Okay. All right. We've done that. We've been doing that. We just, some customers are a little fussy and they
Okay.
don't feel as though it looks very professional at that point. But,
Okay.
that's just what we've been doing. I just wasn't sure if there was something along the lines that.
But that's a great question. I can ask the factory
Okay.
about that.
Okay. No, I appreciate it. Thank you.
No problem. I'll just make a note here. Okay, so moving forward with the pipe is already installed correctly. You will do your pressure test. So because we're using service valve on the indoor unit and the outdoor unit, well, why not making your pressure test and all your vacuum directly inside the house? So you will not have to work outside if it's a bad temperature, it's rainy, it's cold, snowing, whatever. You can bring all your tools inside of the house and you can connect all your nitrogen tank, your vacuum pump, all your stock can be directly connected on the service valve inside the house. So that's another nice thing to know when you're working with those kind of units. So with the Kinghome model, so you can have the connection directly inside the house. By connecting those your gauges and your hose on the valve, just remember that you will have to push pressure inside the suction line and inside the liquid line. It's not connected in any way with the coil because all valves are closed at this point. So you will have to make a separate pressure test and a separate vacuum for your suction line and for your liquid line. So make sure you will hook your two hoses on the gauge and you will make two different tests, one for each line. You will apply for 500 psi. Make sure it's holding for an hour. Okay. Just make sure you don't have micro leaks. Also, you can use your soap to spread it on the flare. Lay it when you're using soap. Just lay it here for 15 minutes minimum. Because if you just spray your soap all around the valve and just wipe it away after 30 seconds, well, it will not work properly. You will have to leave the soap working to dry just a little bit, and then that will maybe you will see some micro leaks after 15 minutes. So make sure your pressure test is high enough, good enough to avoid to have to redo all your stuff because you have a leak or something. When it's done, again, you will hook the vacuum pump, so you will remove your pressure. It's really important. You can live like 1 or 2 psi of nitrogen in the systems before you're starting the pump, just to make sure you don't have moisture or air inside of the system. And then you will have to do 2 vacuums, one for the liquid line and one for the suction line. And then you have to bring your micron gauge attached to the system, and then bring the micron to 500 micron. So the thing is, generally, it won't take a long time to make it because it's only in the piping, so you don't have to bring the coil and to 500 microns. It's only in the piping, so it's very fast. And also make sure when you hit that 500 micron, close the valve, close the vacuum pump, and make sure you hold it for 10 to 15 minutes. If the micron on the micron gauge increase and never stop, and you break the 200 micron barrier, then you have a leak. Okay, so if you are not able to hold the micron below 1,000 for 15 minutes, it's because you have a leak. If it's stable after 15 minutes, if the micron is stable, but you still you are in the range of 102, 1,000 and 2,000 micron, and it's stable, well, the system is tight, you have no leak, but you have some sort of humidity in the system. If you are over 1,000, it's because you have some humidity in the system. If you can hold for 15 minutes somewhere between 500 and 1,000, well, the process is good and you don't have to vacuum more than that. If you hold it like less than 1,000, you're good to go. Okay, so you can open the valve. I will suggest to open always the liquid valve from the outdoor unit first. Okay, so you will push some liquid refrigerant inside of the system, and you will not pull the oil out of the compressor because on the liquid line you will not have this access directly to the compressor. So step by step, you can do a full cycle here with the valve. So you can open the liquid line from the outdoor unit, and then you can open the liquid line on the A-coil, for example, or the indoor unit, and then the suction line on the indoor unit as well. And the last one is the suction line from the outdoor unit. So don't forget, you will have 4 service valves to fully open before you will do your test and all the stuff. So standard length pipe, it's 25 feet away from the indoor and the outdoor unit. The minimum is 10 feet. Okay, so always use a 10 feet minimum as a reference. And if you have, you can fit to 31 feet without adding refrigerant. So because we have those accumulator and liquid receiver, so you don't have to remove refrigerant if you have a 10 feet piping length. Okay, So you don't have to, at any point, you don't have to remove refrigerant on the system. But there's enough refrigerant to feed the systems without adding it till you reach that 31 feet long piping. If you have more than 31 feet, then you will have to add more refrigerant. So 0.36 ounce per feet extra. So that's how you will need to calculate the liquid line only. So only like how long is your liquid line, and everything's over your 31 feet, well, you will add 0.36 ounces per feet. The insulation, make sure you have a good insulation around the valve, around the piping, and all the stuff. Just make sure that will not create some condensate water. Same thing for the indoor unit. So make sure you will wrap the valve correctly by adding some sort of Armaflex around it. Make sure it will not condensate. Okay. And on the outdoor unit as well, you can push your Armaflex around the valve here. But yeah, for sure, at the outdoor unit, it will, maybe that will condensate a little bit, but it's at that point, it's normal. We're gonna move to the electrical wiring. So any more question about the piping? No, we're good. Can go to the indoor unit. So we're gonna talk about the air handler, okay? Because the A-coil, there's no power attached to it. So you don't have to bring power to the A-coil. So we will start with the air handler. So the air handler, you will have different knockouts, okay? One to bring the low voltage wire, your 24 volt wire, and you will have another knockout for your high voltage. In the case that you don't use electric heater, well, you have a terminal block that can receive your L1, L2, and the ground. And so because you don't use electric heater, you just have to provide a 15 amp breaker with a 215 wire gauge, 240 volts. Make sure that you will apply power to that board right here in the blower, and that's it. If you install electric heater as an optional, make sure you will install the right gauges for the power of your electric heater, and so make sure you work with your electrician at that point to make a good connection. So I've just said at the beginning, there's some knockout here on the top, but I will recommend you to not use it, because at a certain point, if you need to remove this top panel here for your installation and servicing the air handler, well, if you pass your wiring through that knockout, you will have some difficulty to move that panel around, and that will create a little mess. So always use a knockout from the side of the unit. It's better for you, and it's easier to work with. If you install the duct heater, I have some slides here just to give you a small overview of what it's looked like when you install an electric heater inside of that cabinet. But first thing first, you will have to remove the electrical box. So you have 2 screws just in front of the box, and you will have to remove it temporary to gives you enough room to install the duct heater. So you will just unscrew the metal plate in the back of the air handler, and you will install your duct heater inside of it. So at the far end here in the cabinet, you will have 2 small holes right here just to push the brackets in it to hold the duct heater correctly. So that's really important. So this is why, you know, here the top panel needs to be removed if you want to have enough space to install this kind of duct heater. And so on the other way here, you will have a breaker, so that can be installed. So as a reference, this one is a 10 kilowatt, so it's using only 1 breaker. If you have more than that, maybe you will have a 15 or 20 kilowatt. So in my region right now, it's most of the time it's 15 or 20 kilowatts. So we always use a double breaker assembly here and a single point kit. It's all available. But for the reference in that picture, it's a 10 kilowatts, so we're using only 1 breaker. And so you reinstall the electrical box right here, and after that you will have this white Molex plug right here. This connector needs to be connected, so you will bring the power directly to the breaker right here. You don't have to bring the power in the electrical box anymore. It will just be applied to the breaker right here. And by connecting this white connector right here, you will apply power automatically on the board and for the blower and all the stuff. So this is just another diagram right here. So you can use the power here to the knockoff hole right here to bring the power to your breaker and all the stuff. The low voltage connection will be at the same place here. So you have your low voltage connection directly on the terminal strip right here. So for the outdoor unit, we said we have only 2 different cabinets, so the 3-ton and the 5-ton. And so the maximum overcurrent protection for the 3-ton is 35 amp. So a 30 amp breaker is high enough to protect the system. And for a 5-ton cabinet, well, the maximum overcurrent protection is 45. So a 40 breaker amp is big enough to protect the systems and the wiring, whatever you will use at that point. So for a 30 amp breaker, a 10 wire number 10 gauge is big enough. And for a 5-ton here, for a 40 amp, 8 gauge is big enough to install this unit. On the inside of the unit, you will have your L1, L2, and ground connection. Make sure the unit is properly grounded somewhere in the house. And on the other terminal, you will have your low voltage connection. So you will have a Y connection that will bring the command for the compressor. The B right here will be the command for the reversing valve, so active in the heating mode. You can have your defrost signal here with the D terminal. That's bring back power to the indoor unit during the defrost cycle. R and C are your 24-volt connection. So R is the power, C is the common. And you have a G terminal here, but it's not in use. Okay, so they're just using the same strip as the indoor unit, but the G for the outdoor is not in use. So, well, I just make it on the wording right here. I had some picture of what it's looked like in real time. So you will see the G here. There's only 2 screws, but nothing to do with it. And so you will have, as I said, your compressor signal, reversing valve, your defrost signal, the R for the power, and the common right here. So on a 3-ton cabinet, you will have your high power right here, low voltage terminal right here, and you can use those knockoff. It can be in front of the unit, it can be on the side, or it can be on the back of the unit. So you have multiple ways to pass the wire and make sure you have a good path to bring the wire up to those terminal strip right here. So make sure you have the wire long enough to just pass through that knockoff and going up inside the cabinet and reach out the terminal block. Same thing for the 5-ton unit. So the 5-ton unit cabinet using a 2 fan. So one above the other. So the unit is taller, and the knockoff is right in the middle right here. So big difference between the first cabinet and the other. This one got the valve connection outside the cabinet. So I can go back here, and you will have inside the cabinet for the 3-ton, you have your piping connection right here. But for the 5-ton cabinet, you will have your piping connection outside the unit. And the knockoff hole will be somewhere here in the middle of the middle sheet, because the terminal strip is high at that point. So your high voltage terminal and your low voltage terminal will be right there.
Hey, Francois, we got a question here.
Yep.
Is the D signal powered through a compressor call from Y, or does it have power always through R and controlled from sensors on the outdoor unit?
Just trying to understand, what do you mean? Well, you don't want to connect the R at that point, or what's the what's?
So with D, if I was to power D from the outdoor unit, because we're talking about basically a furnace, not an air handler hookup. So if I power D to W, if the thermostat reaches set point, will the call from D stop, or will the call from D continue?
It will continue, because in that point the D signal is an output from the outdoor unit. Okay.
So if the unit, so it's powered from R then, so it's always has power, and then we'll send it out. Okay.
So the R terminal here there's a relay inside of the on the board somewhere, and this relay will be active during the defrost. So the R here will be jumped directly to the D terminal, and this D terminal hooked on the W1 will provide the call for the heat.
Okay, so like if the Y, or if the call for a compressor stops, it'll still have an output on D.
Yeah.
Okay, perfect. Thank you.
No problem. So in wording, like what I said is always the same. So the Y means the compressor control signal. So you will have the Y from the thermostat hooking on the Y from the outdoor unit, and you don't have to. Well, obviously, I have a better explanation here about these terminal, how to hook it. So I drew this this schematic right here using an Ecobee thermostat. Okay, and so you will have in that example RC directly on the R of your furnace, and then you will hook that wire directly to the R on the outdoor unit. So you will bring your wire thermostat inside the cabinet of the furnace, and you will bring your heat pump wire inside the cabinet of the furnace. Okay, so that's the better way to install it, and all your connection will be inside the furnace at that point. So it's easier to install, and also for you guys, when you will do some troubleshooting on the unit, well, you will know exactly where is your connection, where is all your stuff. So you don't have to connect directly a wire from the outdoor unit to the thermostat. Everything will go inside the furnace cabinet at that point. So the G from the thermostat will going directly to the G on the furnace, just for your call for ventilation and all the stuff. So you will use your Y1 terminal hooked on Y1 for your furnace, and then it's going back to the air handler, the outdoor unit, sorry. But for the air handler, the terminal strip of the air handler, there is no Y, okay? There is no Y terminal on it. So you will just have to make a connection with the Marette or something like that. So the air handler doesn't have the Y terminal hooked on it. But on a furnace, yes, you have one, and you will need to connect it to make sure the systems will apply the right speed for your, because you have a call to use with the heat pump. So a call, even if it's a cooling call or a heating call, so you will use the same amount of CFM through that coil. So because you need to provide the same capacity through that coil, even if it's in cooling or heating mode. So yeah, with the furnace, you will hook the Y terminal right here, just to tell the system that you have a call for the compressor. You have a terminal called OB on the Ecobee system. And so in the configuration of that thermostat, you need to configure it. This is called for the reversing valve. So it needs to be configured active in heating. So because it's active in heating, we will use the wording B, okay? And so the B terminal will be at a certain point connected on the B terminal on the outdoor unit. But now, because some of label on the outdoor unit is called from the furnace, it's called O terminal. So O and B terminal means the same thing, but O it's when it's active in cooling mode, and B it's when it's active in heating mode. So you just need to know this slightly difference between O-B. Why it's called O-B, it's depending of how what kind of heat pump you're using. So unitary heat pump, by the time so back in it's a couple of years, every reversing valve was active in cooling. So we are using O terminal. So this is why some kind of labeling can be O. But in that case, today for the Kinghome model, everything is every kind of unit from Kinghome, the reversing valve is active in heating mode. So we will use the B terminal. And also for your W1, well, it will be hooked directly on the W1 of your furnaces. And also you can use the D terminal connected on W1. The unit will do the defrost, okay? Regarding the balance point you will use, Okay, so if you manage the systems to not using the heat pump in very low temperature, and the defrost is will take around 1 minute or whatever, at some point maybe you don't have to connect the D terminal. Okay, so what's going to happen if you not connected it? The heat pump will go into defrost cycle. That will provide some cold air inside of the ductwork for 1 minute, and then when the defrost stop, the valve will change its position, and you will bring warm temperature again. So the unit will be in heating mode after its defrost cycle. Okay, so by if the outdoor temperature is not really low, then you will be able to use the defrost for 1 minute or 2 maximum, and you don't have time to feel that cold air going from the ductwork at that point. But if you use the D terminal to active the furnace in that case, so the furnace will be on, and the case coil is in the supply air right here. So you will make the refrigerant boil at a certain point. Okay. So thing that can happen is if the defrost is longer than 1 or 2 minutes, well, you will bring the pressure at a very high level inside of it. So the defrost will be very quick, but when the systems will try to make a heat call again with the heat pump, it may cause you a high pressure trip. Okay, so to avoid that, you can add a limit switch. Okay, so back in the day here in my region, because defrost can take as long as 10 minutes because it's very cold, this limit switch can be installed under the coil, but after the furnace. So somewhere right here, okay? So this is why I told you in the beginning, if you have a transition duct between the case coil and the furnace, you will just have to drill a hole in your transition and put that limit switch directly right there. This switch here can be you can buy. This is not a part that Kinghome sells. You need to find your own limit switch, but you can find one that is open at 100 Fahrenheit. Okay, so this limit switch, when you will have a defrost call, okay, you just passing the D signal inside and out the limit switch. So the furnace will be on, will be active, and when you will hit 100 Fahrenheit, the furnace will stop. So it will short cycle a little bit your furnace, but that will help you to not make the refrigerant hit a certain high pressure issue. And at the same time, the homeowner will not feel the cold air in the ductwork because the furnace is bringing on for a small amount of time, and if the defrost is longer than 7, 8, 9 minutes, the longer it can take, it's 10. Well, if the limit switch close again, the furnace will be bringing back on again, and we will do the same pattern right here. So by adding this kind of limit switch, it's just some tips and tricks I give you this morning. This is some sort of installation I've done past when I was on the field. So it's just tips and tricks I give you. You take it or not. but it's just to let you know what you can do with that defrost signal going back to a furnace. Do you have any question on that?
Switch when you are putting that it should be open at 100 °F. So what temperature it should be come on?
Well, depending on the switch, you can have a switch that is closed at like 40 or 60 Fahrenheit and open at 100 Fahrenheit. So it's just because this switch will be normally closed, okay,
yes,
by using it in a like the normal operation. So it will be
yes,
closed, and because you are in defrost, you will bring some cold air, okay, just here and that in the coil. So at a certain point, it will close, and then your furnace will be on when the D signal will activate the W1. And when you reach 100 Fahrenheit, this switches here will open, so that will cut the power to W1. And so you will continue the defrost cycle of the outdoor unit, but you will not overheat the refrigerant. You will not bring the refrigerant to reach that 667 psi. Is good? No more question on that? Okay. So at the end, make sure your high voltage and low voltage is going through the right knockoff and using the right material to avoid to have just a hole in the systems, and you use your rubber ring or whatever type of connection. And also do not running your high voltage and low voltage wire together. Try to avoid that. Even there's no communication into the low voltage, well, sometimes that can create some issue. And use also proper grounding. This is very important. So make sure all your electrical wiring is good, and it's you comply to your local and national rules for your power connection. So we will go to the test and run, and so here we're gonna talk about the programmation here, most of the dip switch. So at first, well, you already checked all the boxes, like everything is connected properly. You had a good vacuum. You have a good, everything is clean and tight and ready to go. Okay, so things you can do is to program the dip switch. Okay, so why you will do that is because by default we're using two different cabinets, as I said. So you have a 3-ton unit. So this is how the dip switch will be set as a default. And for a 5-ton unit, this is how the dip switch will be set as default. So you can see that's the same picture right here, but one is for the 5-ton cabinet and one is for the 3-ton cabinet. So dip switch number 1, if you are looking right here, if you want to make it a 2-ton, you will have to put dip switch number 1 to off position. So remind in the picture here, off position will be downstream and on position will be right here. So dip switch number 1, it's for the capacity. So if we're looking just at the first cabinet right here, the difference between a 2-ton and a 3-ton is the dip switch number 1. Same thing here with the other cabinet. So the 5-ton, if I want to make it a 4-ton unit, I will just flip off my first dip switch. And that's it. I will have a 4-ton unit capacity. Moving forward with the second one, by default, every switch is on. So the dip switch number 2 means the defrost. So you will use a defrost standard operation for every kind of cabinet, every kind of unit. But if you are in a very cold climate application, or you have strong winds, you have some issue and difficulty with the defrost, you always have some kind of snow or ice around the unit and you're not able to remove it completely, then you will have the opportunity to use a strong defrost. So by flipping off this dip switch number 2, you will engage strong defrost. So the algorithm will change a little bit. The revolution of the hertz of the compressor will be increased a little bit, and the defrost can take a little bit longer. So by doing that, you will remove all the ice, all the snow around the unit, and so that will be the way to set up your defrost. If in the region or in the kind of installation you have some difficulty with the defrost, that's the thing to do. At first, you can just put the power back, put the power off, flip the dip switch number 2 off, and then bring it back on and test your defrost. Number 3 and 4. This is the operation mode. So we've talked earlier about a half-ton unit. Well, there's no half-ton unit, but you can use this operating mode to use the system as a, well, strong mode. For example, if you have a 3-ton, everything is connect with a 3-ton unit. Well, you will use that 3-ton as a standard mode. If you need to bring more capacity to that unit because you want to make it like acting like a 3-ton and a half, you can use the strong mode. So that will accelerate like the algorithm and the compressor speed and everything to act more quicker. So it will act like a 3-ton and a half. So if you have more airflow inside the house because you need to, you have, for example, a room that is very far hand and you need to use more power, more ventilation into the house, and the unit as a 3-ton is slightly just not enough, well, you can use the strong mode and all the capacity of the unit will be upgraded. So it will act like a 3-ton and a half. The reverse can be done too, even if you have installed a 3-ton unit cabinet and it's not a 2-ton will be lower. Well, you can reduce the capacity by enabling the energy saving mode. So you will just have to flip those dip switch. So number 3 off, number 4 on, and you will enable the energy saving. So the compressor will take a little bit longer to operate the algorithm and all the stuff. So it will reduce the capacity a little bit, and the systems can act like a 2-ton and a half. So this is how you can not troubleshoot, but you can fine-tune the systems regarding what the customer needs at the end, or what how you want to set the system for the customer. So if the customers complain because you don't feel enough power and you have a little bit more than 400 CFM per ton, well, you can go with the strong mode and try to hack the unit as a 3.5 tons. On the board, okay,
Awesome.
more, yeah.
Done.
Do you have a question?
Okay. So whenever we are going to change the 3-ton unit from 3 to 3.5 by making the dip switch on, so
Yep.
will the coil will be doing accordingly, or we have to use we are putting the coil 3-ton.
The what?
We have the 3-ton coil inside, but outside
Yes.
unit we have a 3-ton, and we
Yep.
are increasing the capacity from 3 to 3.5 ton outside.
Yeah.
So it can accommodate inside.
No, you don't have to do anything inside. No, it's just because you will bring the compressor to a bigger capacity. Between a 3-ton and a 3.5 ton coil, there's slightly no difference. So we don't have a 3.5 ton coil with the Ultranixx. We just have 2, 3, 4, and 5. But the system will bring more power to the unit and more quicker operation when you set it at strong mode. So this is why it's not a 3.5 ton, but it will act like a 3.5 ton. So the compressor will increase its capacity more quicker, and then the homeowner will feel the warmth a little bit faster, and so the systems will just add more power to the capacity and to the system. So it will just act faster.
Okay, so why we not use the 5-ton unit with the 4-ton coil, and we gonna switch to the 3.5 to the 4, from the 4 to 3?
If you're using a 4-ton unit, then you will have only the option to use as a 5-ton or a 4-ton. So you will have the same dip switches here, but if you have the cabinet with the 2 fans, so the 5-ton cabinet, you cannot have a well, you can set it as a 4-ton, and you can also reduce the capacity a little bit, so it can be a little bit less than 4-ton.
And also, when we're adjusting, regardless sizing, but adjusting eco mode or higher speed mode, whatever, then in turn, do we make an adjustment to our indoor fan speed?
Regarding the static pressure you have.
Yeah. So,
So-
we would incorporate that adjustment as a 0.5 ton adjustment, and then adjust the indoor airflow accordingly.
Well, okay, so that's the point. If you need, for example, a 3.5 tons, okay? So regarding, you will have maybe 1400 CFM, okay, around that. So by using 1400 CFM into the coil, and the system is set as a 3-ton, well, the differential between the return and the supply duct will be reduced a little bit. So this is why the homeowner can complain why the system is not performing correctly, because you will not reach the right temperature because you're passing too much air in the coil. But by using strong mode, you will tell the compressor to act faster and higher capacity. So you will fill that gap for the capacity of the temperature rise in the ductwork. So it will act more quicker. So you will still use the same amount of air, the 1400 CFM, but the performance of the systems will increase. It will act faster. So in that perspective, the homeowner will feel more comfortable, and that will avoid the complaint, because you will you will fine-tune the systems properly.
Okay, so can we use the 4-ton coil?
If you use a 4-ton coil, well, you have to use the 5-ton cabinet and
No.
set it as a 4-ton.
Whenever we are using the outside unit for 3.5 ton, so that we are changing the speed or whatever for the compressor to push more. So can we replace that 3-ton coil with 4-ton inside?
No, I don't. I really don't recommend that.
Okay.
You have to match the sizing of the coil with the sizing of the outdoor unit. So if you put a bigger coil inside of the house, and you have a 1/2 ton more in the perspective because you have a 4-ton unit inside the house and you have only a 3-ton unit outdoor, well, you will always be there will always have a lack of capacity. So we will not be able to fill up properly that coil because it's too big. So the flash point of the inside the evaporator will change, and you will not be able to provide enough cooling or enough heating. So you need to match the coil with the outdoor unit every time. So if you're going for a 3-ton installation regarding how many CFM you will need into that house, then you will go with a 3-ton coil, 3-ton unit. But if you have a you need to have a little bit more CFM in that house, well, yes, you can use the strong mode to increase the performance of the systems to matching the right amount of CFM you need in that house. Is that clear?
Yes, thank you.
Thank you.
Okay. I just go back to my slide right here. So yeah, we have, okay, in that particular unit, it will be corrected with the new refrigerant stuff, but right now for the R410A refrigerant system, the dip switch are upside down. Okay, so you will have to just figure out regarding the manual. Okay, in the manual you have 1, 2, 3, 4, but on the field it's 4, 3, 2, 1, and the off position is up and the on position is down. So you just have to flip the manual or flip your head upside down just to make sure you have a good adjustment. So if I go back just a couple of slides just to give you that example, this is a 3-ton unit. Okay, by default it's supposed to be off, off, on, off, off. Okay, if I go 1, 2, 3, 4, so off, off, sorry, on, off, off. If I go back to that slide right here, so I have on, off. So on right here, it's a 3-ton unit. So that's my capacity switch right here. It's on. So I have a 3-ton unit. If I put it off, I will have a 2-ton unit. The dip switch number 2, it's my defrost. So by to be on by default, my defrost is a standard defrost. Number 3 and 4 means the capacity mode. Okay, so if I go back here, my capacity mode, if there was off, I will be standard. I am on, off, or off, on. Okay, in that case, I am on, off. So if I go there and I look in here, I'm on, off. So that's mean this system is a 3-ton unit, standard defrost, and strong mode. Okay, so this is what it's looked like. If they were off, I will be standard operation. But now, because it's on, off, it's a strong mode active. But this thing will be correct in the future. So it's just for now. Just need to pay attention to that. If you don't manage the fine-tuning at the startup, well, everything is by default correct. So you don't have to change any dip switches. But for technician who will do the servicing afterward, or you have to fine-tune the system a little bit. So yes, you will have to pay attention to the setting of the dip switches. Just make sure, so check and double check before you bring the system on. Even if you have done a wrong application, that will not create issue with the systems. Well, that will not make the system defective. It will be just a wrong application. Okay.
Hey, Francois, Doug's asking a question. What do the 3 buttons below the dip switches do?
Right here. Well,
Yep.
You have a 2-digit display right here, and by using those button right here, you have 3 options you can manage with it. I will for sure. Now it's been well, what time is it? Okay, so I will create another training about servicing the unit and using those buttons. But for now, you can, if you read throughout the manual, you will find 3 operations you can do with those buttons. So you can enter a manual mode, and you can force a heating application, cooling application, or you can force a defrost. Okay, so by clicking the button right here, so you will change some parameter that will appear on the 2-digit display, and so you can, for example, force a defrost, or force a cooling operation, or a recovery operation. So in the case that you need to pump down the system because you have to work on the indoor unit, well, you can force the system to ignore the low pressure switch for a certain amount of time, and then you will be able to do a pump down properly, and well, close your valve and just shut off the power. Okay, so this is what you can do with those buttons right here. But in further weeks, I will well, more trainings will occur on these units, and so I'm about to build a more like high level for servicing and doing some stuff. So stay tuned. We will have more stuff for you on this.
Hey, Francois, just a couple of quick things here.
Yep.
If anyone on this call wants a copy of the installation manual for the Ultranixx, I'll put my email address in the chat box. So just flip me an email and I'll certainly get that to you. And secondly, just doing a time check here, and by no means trying to rush you along, Francois. I know that some people may have to drop off at 11:30 because it was 9 to 11:30. It's about 22 minutes after 11. So is there an idea roughly of just so the folks can understand, where we're going to end roughly? Do you have an idea of that?
Well, I have I will move forward with the economic model right after that slide. So maybe it won't take so long. Maybe we'll be good for maybe 11:45 ish. Okay.
Perfect. Just so everyone knows. Great.
Yeah, no problem. Last thing for the commissioning of the unit. Okay. Everything is connect properly. Everything is good. But in cold weather, when it's cold outside and you can feel, you can touch the compressor, if you don't feel it warm, don't start the unit. Okay. Best practices is to apply power to the outdoor unit during your installation. So if the first thing you can do is the electrical power to the outdoor unit, you are able to do that. Apply power to the outdoor unit before you do your piping and all the stuff, just to make sure the oil inside the compressor will be warmed enough to bring the operation on without breaking the compressor. Okay. Factory will said like needs to be power and preheat for 8 hours. Well, depend of what's the temperature of the compressor. If you put your finger around the compressor and you feel it warm, well, you're good to go. Okay, that's the thing. If it's 30 degrees outside and you don't have to wait any more minutes to start the unit. But in cold weather, when it's very cold temperature outside, well, you need to apply power to avoid to have a liquids return in the compressor, or to make the oil too sticky and just break that compressor. Okay, so just make sure the compressor is warm when you will start it. Also, the heating mode will be disabled if the outdoor temperature reaching more than 24 degrees Celsius. And reverse to that, it's not on the slide here, but the cooling is not enabled when it's minus 15 degrees Celsius. So in that way, don't try to use the heat mode if it's 30 outside. The system will just not go on. Okay. Make sure you complete a startup report sheet correctly. So that will help if you have to call for support. We are just a phone call away, but if you can give enough information on what you have in front of you and what you've done, so a proper airflow setting, what was the return air supply, air temperature, what's your dip switch configuration, what's your power, voltage, all the stuff. If you can have this startup report sheet with you when you are on a call with the support tech support guy, well, that will be very helpful. Okay. Just very quick, do you have more question about the Ultranixx? So I will move forward with the other one. So we're gonna talk about the KD model. KD, it's for the new model series, model number for the economic model. Okay. So this unit, still a heat pump. It's an inverter heat pump. Same thing as we saw with the Ultranixx, but it's a 15.5 SEER2 unit. So again, you will have a built-in 24-volt thermostat compatible. The connection will be 24 volts, and using also some kind of air handler or A-coil to connect with a your outdoor unit. So for this kind of model, we have multiple cabinets. Okay, so you will have to match the right amount of capacity. So we have the 2 ton, 2.5 tons, 3, 3.5, 4, and 5. Okay, so you will need to match up your load calculation regarding the cabinet you will want to use. So it's a different wording. So for the Ultranixx, it was KU24, KU36, for example. Now we're using KD36 for this economic model. So we have different cabinets, okay? For example, the 2 ton, you have here all the dimension, and 2.5 tons and a 3 ton using the same cabinet. 3.5 tons and 4 ton, it's the same cabinet, and the 5 ton, it's a different one. So it's a little bit bigger. So between the 2 ton and the 5 ton, you'll see you will have like 4 inches different wide, and maybe like 3 inches different depth. So you will have some difference, but the this is, you need to pay attention to, this is a different thing. It's more plug and play with the economic model. You don't have to manage all the dip switches and all the stuff, because we're using different cabinet for each capacity. Same thing for the air handler, for example. So we have different cabinet for the matching the capacity. So we will go with the same thing right here. What will be the advantage of using that 15.5 SEER2 unit? Well, we still use the same kind of compressor. We still have a DC inverter compressor and the motor, the condenser motor as well. So we have the same 24 volt compatible terminals for the indoor and the outdoor unit if you are using the air handler. And so the outdoor unit for this economic model has a lower decibel than like all the other competitive one. So it will be, it is very quiet and very easy to move around the house too. Lighter, very light unit, and so it will. This is a very good model. So we're using this kind of the same kind of compressor and the fan. So inverter, as you may know, it's the point is you need to have a compressor is running more time during the day to meet the set point to reduce and increase the capacity. Between the difference with the fixed compressor speed, well, it will be on and off and on and off. Okay, so this is why we're using inverter technology for every kind of units now, because we want the compressor to run longer, but with different capacity to meet the set point. So we will use the same kind of terminal, okay? So you will have a Y, RC, B, Y1, and D for the defrost, okay? So same kind of terminal from the, which is you have a hair handler or with the outdoor unit, okay? That will be the same thing. So no big change between the Ultranixx and the A-coil model. So we talked about a smaller footprint. So yes, if you go with the competition or whatever using a big square heat pump unit with the piping on the corner like this, well, difference with the Kinghome 5-ton units, well, you will have a smaller footprint. It's more easy to install and to do the transportation and all the stuff. So what's really different with this unit is they use a different fan blade. They use so the airflow inside of the cabinet of the outdoor unit is changing a little bit. So it's helpful to reduce the volume and to reduce the sound around the outdoor unit. And also the compressor has a new sound insulation around it. And so this is why the decibel is decreased by 3 to 5 decibel regarding it low on a different model.
So sorry to interrupt. Where is the placement of the reversing valves in these units? How hard are they to get to? How hard are they to swap out? Where are they located?
Well, they're located just upstream the compressor, so maybe at this level right here. But this economic model is a little bit different than the Ultranixx. You have less stuff into it, so the board is completely different, and you have a better access to it. And you will have to remove the entire panel, the front panel here. You don't have a small section that you can remove. You need to remove the complete whole panel here. So that will bring more space to work, and an easiest way to change that. But instead of the Ultranixx have this little door that you can remove right here. But this one, it's a little bit different. You don't have it. So you need to remove the front panel completely.
Okay. Thank you.
No problem. Gree have also improved the outdoor coil. So they adopt the golden fin. So they had a substrate. You have an anti-corrosive material and also an hydrophilic finish. So that's mean that the water will slide more easier out of the coil. Okay, so that will not create some kind of drip. Okay, so the water will not be just sticky around the coil, but that will help to drain a little bit more by changing this kind of condenser conception. So that was this is an upgrade for the factory. They will all move to golden fin, so that will help for the defrost setting and all the stuff to be more manageable, so the water will drip more easy out of the unit. Also, we have different kind of heat dissipation with the refrigerant. So we will use liquid heat liquid cool dissipation process for 3.5 ton to 5 ton unit. So this is what it's looked like. On the board directly, you will have the liquid line, and this board, it's installed vertically. So you will not have water or condensation dripping on the board directly, because it's not an horizontal position, it's a vertical position. And then the liquid line will just go through here and remove the heat from the processor and all the boards, the heat that's coming out from the board here. So that's the liquid cool application. Also, they changed a little bit about the defrost algorithm. So now the systems can do more defrost in a cycle, but it will be shortened. So you can have some heat defrost. It will be like, well, in the other conventional defrost, it was like this, but now they're using intelligent defrost. So what I'm trying to say is they had an AI in the system that will manage all the sensors readings and all the stuff, and they will focus on the right spot to bring that defrost. So by increasing the material of the units and the intelligence inside the unit, well, you will do less defrost, but it will be more accurate, so when you need it. Also, the compressor is equipped with an electric heat belt around it. So this is why you need to, in cold weather, bring power to the outdoor unit, just to make sure this little guy here can be active and warm up the compressor before your first start. So this is what it's looked like inside of it. So you will have this this access here for your high voltage and low voltage connection, and all the piping connection are outside the cabinet. So this is why I said it's more a plug and play unit, because you don't have to remove any panel, you don't have to adjust anything. It's already built in, it's ready to use. So you just have to plug your high power, to plug your 24-volt connection, make your piping, as we said, perfectly fine. Your pressure test is good, your vacuum is good, and then you're good to go. At the A-coil or the air handler, we will use, again, the same kind of service valve. So nothing changed regarding the type of installation. If you have an Ultranixx or you go with an Eco model, that will be the same thing, the same way to connect all those stuff. The air handler using also the same kind of protection. So why they build it like this is to prevent some, to add more safety, okay, around the duct heater. So this is why they put the main control board in front of it, but no big change between the Ultranixx and then the KD model, the economic model. Same thing with the blower. The blower can go up to 1 inch of water column. So for your static pressure, you can go up to 1. It's better to be at 0.4, 0.5, whatever. You will manage your pressure, your amount of CFM. You will take your measurement. So you still have 8 different speed to match different application, but it seems to be, well, it will act as the Ultranixx air handler. So no big change also with the air handler. So this is what the board at the outdoor unit looks like. Okay, so the main board for 2.5 ton and 3 ton, well, it's designed with a heat dissipation by air. Okay, so you don't have this liquid line passing on the coil. It will be an heat dissipation by air. So less stuff around it, but this is what it will look like. You will find some dip switch on that board too, but we will talk later on those dip switches. They will act like the Ultranixx, but less than that, because the only thing you can adjust is the defrost, and that's it. So you don't have to manage more than the defrost with those dip switch. So most of them are not in use for the economic model. So this is why you don't have to open the cabinet. You don't have to make such a thing with this economic model. It's really a plug and play unit. So you have well, different things you can do with those functions. So multi operation mode, okay, but by default everything is standard, so you don't have to manage those. Even if you have well, if you want to do some fine-tuning about the strong mode and energy mode, well, it's up for you. But by matching the right amount of capacity, because we have the half ton now with the eco model, well, you don't have to change that. You still have the ability to do it, but you don't have to. Defrost mode, again, it can be standard. It will be standard by default, but you can move it to strong defrost. And you still have a 2-digit display that will tell you all the error codes and all the stuff. So some kind of protection that the system is using. So you will find an high pressure switch only for 3.5 ton to 5 ton units. Low pressure switch, it's on every model. Every model using high discharge temperature protection. So they have a sensor on the discharge line, and if the frequency is going to be too high, in that example, well, the system will reduce the capacity. You have an overload protection, IPM protection, overcurrent, and sensor failure protection. It's all included with that board. Same thing with the Ultranixx, no big change right here. For the indoor air handler, well, again, 8 fan speed selection. You can change the electric heater safety, and you can manage if you want to avoid the cold air during the defrost signal. So you can shut off the blower during defrost with the air handler to prevent to have this cold draft. A new thermostat is going on also. So it's an optional thermostat, 24 volt, that's it. No big deal about that. It's Wi-Fi compatible, okay? And it's a, well, standard 24 volt thermostat. Nothing, no big deal to say about this. Well, you will have the memory function, all the operation mode. The forward valve can be set as, well, depending which connection you use. O, it's activating cooling, but for our model, we're using B because the reversing valve is active in heating mode. You can do some schedule. You can use Fahrenheit, Celsius, and So you can adjust your outdoor balance point also by using the Wi-Fi. Well, you will have the temperature and all the stuff. Last thing I want to talk about a little bit is we're gonna have, it's not released now, but we're gonna have a debugger, okay, to use with this unit, the economic model. This new debugger doesn't fit with the Ultranixx also right now, but it will. It's downstream this year. We're gonna have more compatibility with this debugger, but for now, this debugger is to work with the economic model. So this debugger will help you to manage how the system is working. So that will open you a window on this unit, and you will be able to see how the parameters, how the EEV are open, what's the sensors readings and all the stuff. So you will have an open window on the unit by using this debugger. This is really a cool tool to have when everything will be available now. So we will be in touch with you guys when you will have this debugger. So you can have your, you can also, without touching the button and all the stuff, directly with the debugger, you can force a recovery, a refrigerant recovery. You can force a heating start or a cooling start, and you can force a defrost. So you can use this tool to servicing a unit very quick. So the purpose of this is to for you to save time with when you are on a job, and you can also save all the data. So you have there's a memory card inside that tool, so you can save the data and expand, send it to a PC or whatever to review the data in another time. I just had a small picture of what it's looked like. So on the economic model, you will find a small connector right here. This connector is to use with the debugger, okay? So you have your high power connection, L1, L2. You will have your low voltage connection right here. But you will find this little connector here, and when you will have this debugger available in your hand, well, it will look like this, and so you will be able to view all the parameter of the unit and force some sort of command or application and all the stuff by using this debugger. So that's the very cool thing about this economic model. So by the installation and all the stuff, no big change. You know how to do it. And so that's it. Do you have any more question for me this morning, or do you have something on the chat?
No, there's it's all good from this end. Real quickly, guys, if you haven't put your name and company in the chat function, if you could please do that, appreciate that. Make sure that we know who's been here, who's done the training, which is great. And yeah, final call out for any questions.
Yeah, so I don't want to take more of your time. You can also reach Chris for sure if you have any questions. We work as a team, so if you have to talk with the technical person, well, you can reach out for me. But in a way, if you struggle with anything, we're just here. We are a phone call away.
Betcha, for sure, Francois, and thank you for your time, and thanks to everyone here today. We took a lot of your time, but we appreciate the fact that you could take this in and look forward to good stuff going forward. So have a good day, everyone, and thank you again.
Yes,
Bye-bye.
thank you. Thank you, y'all.